Hi chemistry students, this is Mrs. Miller, and today we're going to be continuing on with Unit 2, Atomic Theory, and today we're going to be talking about electron configuration. So you likely already have the little cheat sheet or the red reference sheet that looks something like this, that has the filling principles that you're going to need, so you're definitely going to want that as you are going through these notes. There's also a guided note sheet located in Canvas if you want to follow along with this set of notes. Up until this point, we've really focused on the nucleus, being our protons and our neutrons with our nuclear equations like decay, fission, fusion, and so on and so forth. But what we want to know more about is the electron. And from now on in class, we're really going to be focusing on the electron. And we know that electrons are located in orbitals around the nucleus, and they're actually much more complex than what we represent in class. So in other classes, you may have seen this is what we call a Bohr model. This is a super simplified model. In reality, we're going to see orbitals look like these crazy balloon animals, essentially, but we're going to represent them in a different way that makes it easier to keep track of. What we want to talk a little bit about is our orbital sublevels and how our electron orbitals are actually going to be divided by a few things, but one of those things is what we're going to say is our orbitals have letters. So we have 4 letters that we can have here, and we have the s orbital, p, d, and f orbitals. So an s orbital is our smallest, get it, s smallest, and they can fit 2 electrons. So sometimes it looks like this, where we have a little box. Other times you might see something like 1s, and it only has 1 line above it, so on and so forth. But we can fit 2 little electrons in there by going 1 up, 1 down, okay? So it's like you have 1 bunk bed, okay? So if you remember back to that POGIL activity, it's like a bunk bed. The p orbital can fit 6 electrons. So that would be like what we see here, this 2p. It's like we have 3 bunk beds, so you can fit 6 electrons. The d orbital can fit up to 10 electrons because it has 5 bunk beds. And the f orbital can fit up to 14 electrons. It's like we have 7 bunk beds that we can fill there. So that is why our orbitals have these letters. It's to indicate how many electrons can fit in there. And on the next slide, I'm going to show you why this makes sense with our periodic table. Now that you guys understand a little bit about the S, the P, the D, and the F block, I want to show you guys why these make sense. So the S block is going to be the first 2 columns, including helium, because if helium was in the appropriate spot, it'd be here based on valence electrons, but because it's a noble gas, it's over there. So 2 columns, which is why we have 2 electrons in the S block. P block, it can fit 6 electrons. Guess what? It is 6 columns. D block can fit 10 electrons. I bet you can guess that it's 10 columns. And last but not least, we have the F block, which has 14 columns, and it can fit 14 electrons. So knowing where these are in the periodic table is very helpful. So if I want to know how many in this P block, you could figure it out just by counting across, and it has 6 columns. So here's another way to look at our orbitals. You can see that we have our S block, P, D, and F, and as I mentioned, it's the number of columns that determine how many electrons go in each. The other thing I want you guys to notice is that it's also accounting for rows. So when I say we have something in the 1s orbital, that means here. So if I said I had something, I was looking for 1s2. Guess what? I'm going to look in the first row in the S block with the second one. Okay, so I'd be looking for that. So here we see the 2, 3, 4, 5, 6, 7, and so on. The one thing I do want you to notice is that 3 continues right here. For whatever reason, we have the 3D, just because that row or that area has less energy than the 4s does. Or more energy, I'm sorry, than the 4s does. And then the 4f and the 5f actually fit right here. So just be careful of those. As we start to fill these things, one thing that we want to keep in mind is that electrons are always going to fill orbitals that have the lowest or least amount of energy first. We're always going to use the same order, and you guys should have a reference sheet that looks exactly like this. It's probably a little half sheet of paper, but we are always going to follow this pattern. We don't deviate from the pattern. So as long as you have your sheet of paper in front of you, this should not be an issue, okay? The smaller the number in front, the lower the energy. That's why we have 1s, then the 2s, then the 2p, and so on and so forth. So what we're going to do here is this is where we are always going to start. So our starting point is here. We're going to fill up the 1s block first, and then our arrows come back and they wrap. So then we go to the 2s, 2p, 3s, 3p, 4s, and we just keep going down the line. So if you want to make your arrows so that they go like this, you're always going to fill in that order. Do not deviate from the order. All right, everyone. So what we're going to do here is we're going to do a sample problem where we're going to write out the electron configuration for an atom whose atomic number is 18, okay? So if the atomic number is 18, we also know that in this case we have 18 electrons that we have to fill. We know that in every s orbital we can fit 2, p's can fit 6, d can fit 10, and f can fit 14. And we're always going to start in the same spot, so we're going to start with the 1s. I know that the s orbital can fit 2 electrons, so I'm going to go 1s2. And notice that is a superscript 2, okay? So 1s2. Next, I'm going to loop and I'm going to go 2s2. To figure out how many electrons you have at this point, what I'm going to do is just take these two values, add them, okay? So right now I'm accounting for 4 electrons. I need quite a few more, 14 more, until they're filled, so I'm going to keep on going. So now I'm going to go up to the 2p. I can go 2p, and now I can fit 6. So if I count these up, I have 6, 7, 8, 9, 10 electrons. I still need 8 more, so I need to keep going. Next, I'm going to go to the 3s. 3s, and I know I can fit 2 there. Now I have accounted for 12 electrons. That's awesome, but I still need more. So I'm going to go up here to the 3p. So I have 12 here. I need 18, so I need 6 more. And I can fit that completely in this p orbital. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6. And again, these are all superscripts. So just keep following that road on down until you have enough. If I would have said that I wanted 17 instead, I would have gone 1s2, 2s2, 2p6, 3s2, and then I could have gone 3p5. Okay, so that would be how you would do that. You don't have to fill in every single orbital. Another cool thing about this is we can figure out the number of valence electrons, or remember outermost. And these are involved in bonding. And all we have to do is look at the electron configuration. What we're going to do first is you're going to identify the outermost shell. So what's your largest number? In this case, we have 1, 2, 2, and 3. Guess what? 3 is the largest. So anything that had a 3 on it would be part of your valence electrons. And then you just count how many. So 3s2, we have 2 valence electrons. If I want to do something different and I wanted to get something like oxygen here, okay, oxygen is a 1s2, 2s2, 2p4. So this time what I'm going to do is I'm going to find the values that are biggest, 1 or 2. Guess what? The 2 is largest. And now what I have to do is I need to go through and I need to add my valence electrons. And when I do that, 2 plus 4 equals 6 valence electrons. Why is that important that we know what the valence electrons are? Well, it helps us with drawing Lewis dot structures. So here we have a sample problem where we're going to write out our Lewis dot structure, which is just the symbol and the valence electrons for the following elements. So remember, put a dot on each side before pairing them. So what I want to do is I want to find where these are going to be located on the periodic table. So I'll give you guys a moment, find both CA and BR. CA is number 20, BR is number 35. So if you guys remember, the way that we figure out valence electrons can be found from columns. So if we look, we find calcium, number 20, is going to be in column 2. And bromine is going to be in column 17. So if you're in column 2, guess what? It's really easy. It has 2 valence electrons. If you're in column 17, also pretty easy. We cover up the one in front, so it has 7 valence electrons. So what we're going to do for these, I'm going to just switch colors quick. So for calcium, we start by writing out its chemical symbol in the middle. And then what we're going to do is, you can start on any side you want. I tend to start on the top. And you're going to give 1 valence electron per side. So we have 4 sides, right? Top, bottom, left, and right. And then you can start pairing them. So if calcium just has 2 valence electrons, guess what? 1, 2, boom. Done with that valence electron problem, that Lewis dot structure. Bromine, going to be a little bit different. We have 7. So I'm going to start by going 1, 2, 3, 4. Each one gets 1, each side gets 1 electron before I start pairing them. So I have 4, 5, 6, 7, and then that's where we're going to stop. So each side can have 2, and then you have to put 1 on each side before we pair them up. So that's how we would do calcium, because it's in column 2, it has 2 valence electrons. Bromine is in column 17, so it has 7 valence electrons, so it gets 7 dots around it. When we start thinking about orbital notation, now we're going to draw the actual orbits. So oftentimes, orbitals are going to act like bunk beds. So does this look familiar? Remember, you guys were looking at this on the POGIL activity that you did? So we have bunk beds. Everyone is going to want their own bunk first, and then we can start pairing up the bunks, okay? So what we see instead of a house like this is oftentimes we are going to see boxes to show those orbitals. The S orbitals, as you can see, they have 1 box like 1 bunk bed. When you look at a P, it is going to have 3 bunk beds. That's why it can fit 6, right? This one can fit 2. And when you look at the D orbital, we have 5 bunk beds, right? That's why we can fit a total of 10. F orbitals are going to have 7 bunk beds. That's why they can fit 14, so that makes sense there. As we start to write in orbital notation, it's important that you understand how to draw these electrons. So a single orbital can hold a maximum of 2 electrons. So if we have a top and a bottom bunk, we can only fit 1 person on the top bunk, 1 person on the bottom bunk. And the biggest thing is they must have opposite spins. So what does that mean? Well, when we're actually drawing them, we're going to have an up arrow or a down arrow. Again, I'm very lazy. I draw half arrows for these. If you don't like that, feel free to draw a full arrow. Okay, so I can have 2 electrons here, 2 electrons here, and then you cannot have 2 arrows pointing up in the same orbital. So if instead I went up, up, that's wrong. And I also can't do down, down. They have to be different within the same orbital. In the different orbitals, so we have 1 orbital here, 1 orbital here, we can start putting 1 on the top bunk first, and then we can put 1 on the bottom bunk. And that leads us to this one, how we fill our orbitals. So when we're filling orbitals, we want to put one electron in each orbital by itself before we pair it up. So everyone wants their own bed first, right? You don't want to have to share with anyone around you. Even if you have someone on the top bunk, you can hear them snore and stuff like that. That's annoying. So we want our own areas. So think about bedrooms when your extended family's in town. You'd probably like to put one person in each bedroom until you have to start sharing. So here's a good example. Lithium, we put this person in their own bedroom. Then we can put them and match them up to fill that orbital up. Once you get to boron and larger, you get your own bedroom. You add one more, guess what? We have another bedroom. So we're going to put a person by themselves. Nitrogen still gets their own bedroom. Darn oxygen, we get too many, so we have to start pairing someone up, but these two are still by themselves. We're always going to fill this first orbital first. Fluorine, we get another match, then neon, then we're going to fill. So one by itself first, and then we can start pairing them up. All right, so what we're going to do now is we're going to practice one with orbital notation, and we want to go to the atomic number of 23. So think about it like those bunk beds again. S can fit the 2, P can fit 6, D can fit 10, and then F can fit 14. We're going to start with the 1s orbital. So the way that I draw that is 1s, and it's like having one bunk bed. So I can go 1 up, 1 down. After that, I'm going to go 2s. Still like I have one bunk, 1 up, 1 down. Now I go 2p. When I have a p orbital, it's like I have 3 bunk beds to fill. And I'm going to go up, 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 down, down, down. Okay? So at this point, I have filled 10, but I need 13 more, so I have to keep going. So I'm going to go to my 3s, which is just one bunk bed, and I'm going to fill it. Now I have 12. Now I go to the 3p. P orbitals again have 3 bunk beds. 1 up, 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 down, down, down. We get our own bed before we start pairing. So at this point I have 18. Gonna keep going to my 4s. Now I have 20. So I'm almost there. I just need 3 more, and I'm going to go to the D block. I'm going to put this below just because it makes a little bit more sense because I don't have enough room. And I'm going to go 1, 2, 3, 4, 5 because it's like we have 5 bunk beds when we have a D block. And I'm going to go up, 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 and stop. The reason why I stop now is because I'm at 23 for my electrons, and I can count all my arrows, and if you count them, you have 23 there. And I go up, up, up because I want them to have their own bunk before we pair them. So that's how we do orbital notation. If you guys have any questions, let me know.